Welcome to this explainer. Today, we are tackling a notoriously tricky subject, and to do it, we're putting on our paleontologist hats. But listen, instead of dusting off dinosaur bones in the desert, we are excavating method marks from complex Cambridge AS and A-level computer science questions. Specifically, we're targeting course code 9618 and an absolutely critical skill: constructing truth tables from logic circuits. Picture the exam room for a second. The timer is ticking down, the tension is high. Let's look at two typical students taking this exact exam. First, we have Alex. Now, Alex overloads his answers with raw computer science facts. He's memorized the textbook, sure, but there's absolutely no analysis in his work. Then we have Sam. Sam rushes. Sam completely misses the specific command word requirements in the prompt. When you look at their papers side by side, it is just a sea of red pen marks where they've lost points they should have easily secured. We are going to fix that today. We're going to dig through the fossil layers of these question parts and reconstruct the perfect full answer. Let's get started.
Okay, let's dive into this. We have a direct quote here from a Cambridge senior examiner who states unequivocally that mastering this topic is essential because it appears in literally every single examination series. I want that to sink in for a second. You simply cannot avoid logic circuits. There's no way around it. It is the absolute perfect place to master our systematic excavation strategy because you know for a fact, 100% certainty, that you will see this on exam day. Mastering this isn't just a suggestion, it's a foundational requirement for securing a top grade. It's the bedrock of the entire exam.
Here is our blueprint for today's dig. We'll start with the truth table challenge, move into the core theoretical architecture, break down the step-by-step method, jump into critical analysis and evaluation, and wrap up with the top 3 examiner warnings. Section 1. The Truth Table Challenge.
It's a really fascinating phenomenon to consider. Why exactly do students find multi-step calculations and method marks so incredibly hard to secure? Usually the issue isn't about knowing the facts. Both Alex and Sam know what an AND gate or an XOR gate does. The real failure is failing to show the digging process. When constructing a truth table from a complex logic circuit, examiners do not just want to see the final string of ones and zeros at the very end of your paper, they want to see the meticulous brushwork you used to uncover it. Remember Alex? He just slaps down raw facts, getting 0 method marks because he doesn't show his working. And Sam rushes right past command words like evaluate or construct and just writes a generic summary. The challenge is shifting your mindset from just blurting out an answer to systematically showing how you arrived at that answer.
Section 2. Core theoretical architecture.
So the crucial point here is that examiners are explicitly looking for systematic analysis and evidence-based reasoning, not just rote memorization. The theoretical architecture of logic circuits relies on precise definitions and understanding causal relationships. You need to know exactly how changing a single input at the start of a circuit cascades through various gates to ultimately alter the output. You really have to understand the why, not just the what. This is where we decode the command words and apply what top students use, the PEEL framework. That stands for point, evidence, explanation, and link. You make your point about the logic gate, you provide the evidence from the inputs, you explain the causal relationship of how the gate processes it, and you link it back to the final output. Now, before we continue and look at how to perfectly apply this PEEL framework, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. It's the best way to make sure you're getting all these high-level strategies.
Now check this out. There is a fascinating secret revealed straight from the principal examiner reports. Candidates who reference cross-topic connections achieve significantly higher marks. Tying truth tables to other syllabus areas is exactly what separates the top-tier candidates from the rest of the pack. For instance, connecting the hardware logic of a circuit to how a software algorithm might implement that exact same logic demonstrates the kind of holistic, big-picture understanding that examiners absolutely love to reward. It shows you're not just memorizing isolated facts, but you actually comprehend how the entire computer science ecosystem works together.
Section 3. The step-by-step method.
Let's move to the practical application and see how this builds. Here's our 5-step digging framework, your complete computer science success blueprint for any logic circuit problem. Step 1. Deconstruct the question line by line. Underline those command words so you don't end up like Sam. Step 2. Extract the relevant data and inputs. Pull out exactly what conditions are being tested. Step 3. Select your analytical framework. This means breaking the complex circuit into intermediate columns on your truth table. Don't try to do it all in your head. Step 4. Execute the logic with extremely clear notation. Step 5. Present the final table with correct, syllabus-approved terminology. Algorithmic thinking requires this exact decomposition. If you skip a step, you leave method marks buried in the dirt. This is where the strategy really, truly pays off. Remember, marks are heavily awarded for the process. If you only write down the final output column for a massive multi-gate circuit and you happen to make one tiny little arithmetic error, you get 0, nothing. But if you show the procedural framework, if you test thoroughly, apply the PEL structure in your mind, and explicitly show intermediate gate outputs, you secure those valuable method marks even if your final bit flips by accident. You're documenting your excavation. Imagine watching those red pen marks on Alex and Sam's papers magically transforming into green check marks. That's what happens when you rewrite your approach using these exact 5 steps. You're literally proving you're working to the examiner. Stop scrolling for just a second. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
Section 4. Critical Analysis and Evaluation.
Top-scoring candidates behave a lot like true research scientists. They demonstrate what we call evaluative thinking. Let's do a quick interactive data scan challenge right now. Imagine a complex computer science data table on your screen, showing different logic gate setups. If a question asks you to analyze that circuit, top candidates will immediately consider multiple solutions, perhaps pointing out how a circuit could be simplified using fewer NAND gates to achieve the same result. They analyze the trade-offs, like the hardware cost versus processing speed. They acknowledge the physical limitations of the system, and most importantly, they justify every single decision with hard binary evidence from their truth tables. Now let's do a find the flaw challenge. Imagine Sam wrote this sentence: "The circuit works because the gates change the inputs." Do you see the flaw? It completely lacks causal evidence. It loses marks because it doesn't justify the decision with technical specifics. You have to explicitly link the input state through the specific gate's function to the output state.
And this brilliantly illustrates the stark divide between an average answer and an exceptional one. A generic response just gives textbook definitions. It's the classic Alex mistake, vomiting facts onto the page. But the examiner alert highlights that you must provide context-specific answers. Anchor every single point directly to the given scenario. Let's do a speed writing challenge. You have 30 seconds in an exam to write a perfect paragraph. If the logic circuit is controlling an automated greenhouse, don't just write, "The output is 1. That's generic. Instead, use the PEL framework and write, "The output is 1, which activates the sprinkler system because both the temperature sensor and the timer inputs are high, satisfying the AND gate condition." Boom. Context-specific, precise, and guaranteed full marks.
Section 5. Top 3 Examiner Warnings. Listen up, because these 3 warnings come directly from the Cambridge Principal Examiner reports, and they are the biggest reason students experience mark cave-ins. Number 1, answers are often way too vague. Examiners don't want generalities, they want highly specific technical terminology. Don't say "it turns on." Say "it outputs a logical 1." Number 2, students constantly forget to check boundary conditions and edge cases. In truth tables, this means you absolutely must test every single binary combination, ensuring your rigorous testing covers the extremes, like when all inputs are 0 or all inputs are 1. And number 3, which we just practiced, answers fail to be specific to the question context. If the question gives you a real-world scenario, you better use the nouns and verbs from that scenario in your final answer. Always link your technical details back to the prompt.
To avoid these classic mistakes, the research suggests a fantastic retention technique. Use a visual story method to encode these concepts. Seriously, to remember how different gates function, turn them into a story with characters. Picture an AND gate as a super strict security guard at a concert. He only opens the door if you have a ticket and a valid ID. Both must be true. Picture an OR gate as a super friendly host at a party who lets you in if you have an invitation or if you brought snacks. Just one needs to be true. Connecting these rigid mathematical rules to a vivid narrative story makes them incredibly sticky in your mind. This ensures you can quickly and accurately recall precise definitions even when you're under the immense pressure of the exam clock.
We've covered a massive amount of ground today, from the theoretical bedrock to our interactive speed challenges. To sum it all up, your complete computer science answering system relies on 3 golden rules that guarantee top marks.
Number 1, command word decoding. Number 2, rigorous Peel framework application. And number 3, a time management matrix that ensures you have the time to actually write out those intermediate truth table columns. Students who implement these computer science strategies see an average improvement of 2 full grade boundaries. But that is only if they practice consistently with our weekly explainer videos. So here's your final reminder. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by without having the best strategies in your toolkit. I want you to drop a comment below right now with your target grade for computer science and the biggest challenge you're currently facing. Our team responds to every single comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here. Keep excavating those method marks, and I will see you in the next one.